Hey guys, Mr. King here. Today we're going to talk a little bit more about atoms, and we're going to talk specifically about what's inside the atoms and the number of different subatomic particles they have inside them. And those different atoms come together to make what's called elements. And you guys have probably all seen the periodic table of elements before in a science book. We're going to talk about what those things mean, where they're listing the numbers and the different symbols. We're going to learn all about what those periodic blocks mean. So to start out, we got a little video here about the elements from Professor Fuzzlemuth is his name.
There's antimony, arsenic, aluminum, selenium, and hydrogen, and oxygen, and nitrogen, and rhenium, and nickel, neodymium, neptunium, germanium, and iron, americium, ruthenium, uranium, europium, zirconium, lutetium, vanadium, and lanthanum, and osmium, and astatine, and radium, and gold, protactinium, and indium, and gallium, and iodine, and thorium, and thulium, and thallium.
And if you notice in the top right-hand corner, there's the periodic block.
Actinium, rubidium, and boron, gadolinium, niobium, iridium, and strontium, and silicon, and silver, and samarium, and bismuth, bromine, lithium, beryllium, and barium. There's holmium and helium and hafnium and erbium and phosphorus and francium and fluorine and terbium and manganese and mercurium, molybdenum, magnesium, dysprosium and scandium and cerium and cesium and lead, praseodymium and platinum, plutonium, palladium, promethium, potassium, polonium and tantalum, technetium, titanium, tellurium and cadmium and calcium and chromium and curium. There's sulfur, californium, and fermium, berkelium, and also mendelevium, einsteinium, nobelium, and argon, krypton, neon, radon, xenon, zinc, and rhodium, and chlorine, carbon, cobalt, copper, tungsten, tin, and sodium. These are the only ones of which the news has come to Harvard. And there may be many others, but they haven't been discovered.
So all those elements come together to make all the different things in the universe. And all of those elements either are naturally occurring or they've been created by scientists in a lab somewhere. So elements are matter made up of only one kind of atom. So if we're talking about the element oxygen, we're talking about just a bunch of oxygen atoms. Elements are pure. In other words, you don't take two different kinds of things. You don't take oxygen and carbon and join them together to get an element. That would not be an element. An element is made up of only one kind of atom. So if you have a bar of gold, it is made up of only gold atoms, if it's pure gold. There are 118 known elements. Your textbook says 115, but it's a little outdated. 92 of them are naturally occurring. In other words, they're just here on Earth. Nobody had to make them. They've been discovered here, and those elements are used for a variety of purposes. Now, scientists have been able to create 26 elements, and those are called synthetic elements. And those elements are made by taking different things and crashing atoms into each other, and you get different things that show up. Sometimes they last for a very short period of time and then they change, and other times they're very stable and last for a long time. So as you can see, there's a lot more naturally occurring than ones that are synthetic that have been made by scientists. So here's that periodic table of elements, and you guys have probably seen this before, like I said in your book. You can look, and there's obviously a lot of letters on here. Those are the element symbols. But then there's also a bunch of numbers on here. And today we're going to be talking about what all those numbers mean. The periodic table is also organized by categories. They're in rows and columns based on their characteristics. So they're organized by, if they are the same, types of things. So here's one of those periodic table blocks. This is for carbon. And you can see that number up top, 6, is carbon's number. And if we go back here to the periodic table, you can see carbon is up here, number 6, up on, if you just follow in numerical order, you can count the carbon up there. The number 6, what that tells us is that carbon has 6 protons for each carbon atom, and it also has 6 electrons. So there are 6 protons in the nucleus of a carbon atom, and then there are 6 electrons kind of floating around in that electron cloud area. Element symbol for carbon is a C, and then the atomic mass is that number down at the bottom, 12.011. That is the average mass of the isotopes of an element. So in other words, if you take all the atoms of carbon, that is the average mass of those atoms. Now the mass is made up by the protons and the neutrons and the electrons. When you add all that together, the average mass of carbon is 12.011. Now, every atom of carbon, no matter what, is going to have 6 protons. If it didn't have 6 protons, let's say it found an extra one, it wouldn't be carbon. Look next to carbon up there. The number 7 is nitrogen. So any atom that has 7 protons is nitrogen. So carbon is always going to have 6 protons. That will never change. The number of neutrons is a little bit different, and that's where we get this thing called an isotope. Let me go to the isotope real quick here. Isotope atoms of the same element, they have a different number of neutrons. So this is all carbon, and you can see the protons are the purplish ones, and in each one of these atoms there are 6 protons. You can count in each example in the first, the second, and the third. You can count 6. Now if you count the blue subatomic particles, those are the neutrons. In the first atom of carbon, there are 6 neutrons. In the second one, there are 7 neutrons, and in the third one, there are 8 neutrons. Now this is what an isotope is. It's where you have the same number of protons, but a different number of neutrons. And once again, if you change the number of protons, let's say there was not 6 protons in this nucleus, it would not be carbon. So isotopes are atoms that have the same number of protons, but a different number of neutrons. And we take that to get this number, 12.011. You can see that in carbon, you can either have 12 protons and neutrons, because you've got 6 of each in the nucleus. That's the first example. You can have 13 if you have 6 protons and 7 neutrons in the second example. And then in the third example, you can have 6 protons and 8 neutrons, which would equal 14. Now what the number tells us here on the bottom, our atomic mass, 12.011 is the average mass of the carbon atoms. That means the most common one is the one that has 12 subatomic particles in its nucleus, because 12.011 is closest to the number 12. So the most common atom of carbon looks like this first one, with 6 protons and 6 neutrons. You can see in this example there are 6 protons, those are the blue ones in the middle, and then there are 6 neutrons, are the yellow ones. This is the most common atom of carbon. And then there's also 6 red electrons. Now remember that number 6 on the periodic block for carbon tells us the number of protons and electrons. Now the electrons change once in a while, but for our purpose we're just going to start with that is the number of electrons that the atom would have. So we know the number of protons and neutrons, or protons and electrons, are pretty easy to find. You just look at that top number on the periodic block. That tells us the number of protons and electrons. To find the number of neutrons, you have to do a little bit of math. So you're going to take 12.011 and you're going to round that to the nearest whole number. 12.011 is closest to the number 12, so you would round it to 12. Then you have to subtract the number of protons, which is 6. You can see that up top, that number is given there. So 12 minus 6 equals 6 neutrons. Now that makes sense because there's only 2 types of subatomic particles in the nucleus, protons and neutrons. And so if you have 6 protons and you have an atomic mass of 12.011, that makes sense because 12 minus 6 means there's room for 6 other subatomic particles, which are neutrons. So that's the way you can find each one of those different subatomic particles. Protons and electrons are pretty easy. That's given right on the block. So if we go back to our periodic table back here on the periodic table of elements, you can look at all these and they're in numerical order. You can see they go 1, 2, 3, 4 from left to right. Those numbers tell you how many protons and electrons each one of those atoms of those elements has. In order to find the neutrons, that's where the math part comes in. You have to do a little bit of subtraction, and it's a little more work, but you can still find those numbers pretty easily. The mass number is the number that is given when you're talking about an atom, and the mass number is the number of protons plus the number of neutrons. And so the mass number of this carbon atom is 12. It's got 6 protons and 6 neutrons, and 6 plus 6 is 12. So this isn't just known as carbon, this is known as carbon-12. And if we go back to our example where we had the different isotopes, This first one would be named carbon-12 because there's 12 subatomic particles in the nucleus. The second one, what do you think that one would be named? You got it. It would be called carbon-13 because there's 13 subatomic particles in the nucleus. And the last one would be carbon-14 because there's 14 subatomic particles in the nucleus. Now the reason they're all carbon, because they have 6 protons. And when we look at our periodic table of elements, you can see carbon has 6 protons. Once again, if we change the number of protons, we're no longer talking about carbon. We're talking about nitrogen if it has 7 protons. Or if it lost a proton, that would be boron. Okay, so it's always going to have the same number of protons. Carbon, no matter what isotope we're talking about, will always have 6 protons. The number of neutrons can vary. Okay, that can be, you saw in the example that some had 6 neutrons, some had 7, and some had 8. All right, guys, I know this is kind of a lot to take in, but we're going to get used to a couple of these vocab words and what they mean, okay? Most importantly here, the main things that we're going to be talking about, and they almost sound the same. We're going to talk about the atomic number. That tells us the number of protons and electrons. We're going to talk about the atomic mass. That's the mass of all the atoms that exist. And then the other one that we're going to talk about is the mass number. And the mass number, once again, is the number of protons plus the number of neutrons. All right, everyone, I hope you are understanding this. I know it's a little bit confusing, but we're going to get through it. When we talk about the mass of the atoms, we use the atomic mass unit is the name of the unit we measure it in, just like if we're measuring distance, we measure in meters or kilometers. So if you're talking about how much mass an atom has, we call that the atomic mass unit, which is given the symbol U. And so that's how scientists can write that down so we know how much mass is inside the atom. All right, guys, good luck on the quiz. Write some good questions. Let's have some good discussions tomorrow in class, and I'll see you then.